Yes, it is recording.
So, hey folks, thank you so much for hopping in for the session. It means a lot when we have much of an interaction in terms of an in person, but like, sorry for that. I stay in a very long distance, so keeping that in mind. Hosting an online session is the best part about it. So, today it's not about me talking a lot of tech because it just gets too boring when we talk a lot of tech because I've understood one thing that what world of AI and deep learning is literally going to evolve. Let it be tomorrow or else any day that you're going to think, it's just going to have a chance to evolve because a lot of times when you just get that brief understanding about like what is that industry inside that we just require right now, probably there are hundreds of things that I and you don't know today. Like probably I'm looking for something new, you're looking for something new, right? So let's just understand that based on some of the problem statements that we can just understand to some of the things. And I think this is my YouTube channel. Do subscribe to them because I do a lot of things. It's a podcast, a DevOps chat series. I just talk with a lot of DevOps folks as well. Follow me on LinkedIn because in LinkedIn, I do keep hosting a lot of live interactive events, so you guys can check that out as well. So, a lot of resources today, a lot of resources to be covered. So, let me just start with that basic understanding of like how does an image look? How does an image look in digital art or something like that's what we want, right? So this is what we want in the digital art as pixels. But to be very frank with you, in your same old monitor, it's divided in the same old way. So if I just open this right now, there are a little bit of in segments, and that's basically your LEDs popping out with some values. Probably there is an value for it as well. So it's all analog at the end of the day. So when you think of all these kind of an image processing happening behind in all your applications, it's all at the end of the day. It's that massive amount of input and output that is just being processed at that one given point of time. So now, to be very frank with you, there are hundreds of ways in which you can do a mathematical operations on it, but one one thing that really popped out for any of the engineers is that convolution is one of the best ways to do it. So if you're an ECE person, electronics and communication engineering guy, you'd have obviously studied one subject exclusively on convolutions, probably two, maybe three sometimes. I don't know about that, but like you would have studied a lot about the convolutions and things like that. So what does all these subjects do for you? It's very simple. So they just give you the mathematical understanding of the similar processes that are happening. I think there was one more book uh, which I could actually recommend, but I forgot the name of the book. It's been a very long time since I read that. It really gave me that insights for neural networks. So in a calculus term or things like that, this is how the definition of it looks like. It's convolution of two elements. I think I'm taking it from sources, so keep that in mind. I'm not a slides guy. Of course, I do have a lot of slides, but I can show that in the end of the show. So don't worry about that. So to convolve a kernel, this is how it is, and I think this is how you can see that. So let me just open this image. So if you can see that this is a filter, this is what convolution filter looks like, and this is a source pixel that can be a source image. But after processing, at the end of the day, there is one destination pixel that has been generated. So if you know this filter, you can get this value out from this filter as well. So the original image can be obtained from the destination image as well. So keep that in mind. It's just mathematical operations that is known to people. But in deep learning, this has to be automated. So I talk a lot of DevOps. It's because of that only. Because here you're strategizing about how to automate the things by using the same old formula that is given here, but the same old understanding that we have about the image, but the same old calculation and the processes that just goes behind all these things. So a lot of things just changes, a lot of things is very dynamic here. So just keep this in mind, it's just going to evolve a little bit of a time, but it's worth it once you have that in mind. So keep all these things in your mind, because all the explanation that I'm going to give in the future, it's just going to be the same old mathematical formulas that are just going to evolve. So this is how it is. So keep this in mind. So everything that I have today, it's all in an order. So I'll be sharing this link as well. So don't worry about that. So this docs is open for you folks. I think if you want, you can just go back to my slide share. Maybe slide share, which was an 8. Wait, yeah, this is the one. So I think I have 41 slides, different technologies like missile system, Onyx, cognitive services from the Azure. There are serverless, IoT, satellites, you name it, I've done it. So kind of a thing. So you guys can just go out and check out all the things that are there here. I think these are going to be something that is going to be required by you in the future. So keep that in mind. So if you want something, just go grab it. So I think 41 slides, pretty much it. I think 2 followers. Who are they? All right. Fine. Perfect. You can just go out and see all my slides there. So let's just go for my first slide, which is based on NumPy. But I think I have NumPy cheat sheet project.web.app. This is one of the websites that you guys need to follow, because a lot of times, when I go for a NumPy lectures, NumPy is actually changing. NumPy is actually evolving every single time that you just think about. So NumPy is just going to change. So I'm calling out contributors here. So if you guys are actively willing to contribute, come on, let's just go and contribute right now. So all right, so this is how you run it. Shift enter, collab runs it smooth as silk. Just go ahead, because all of these things are number of dimensions that you can talk about. So very simple. Import numpy as numpy, which is numeric Python, which is used for operating all your matrices. So why do you require a numpy? Because a lot of times when you want to do some sort of an operations, those operations will really take a lot of time, and a lot of computation power is required. I can't really afford that. So back then, when you ask me like, how are we just going to do the same old computation, the same old things that is required for us in order to be sustainable in the market and things like that, they used to optimize to the core. And I think NumPy from NumFocus community, I think, sorry for that. All right, NumFocus community. I don't know, it's a community or an organization. Like, it's a community at the end of the day. Open source community, anybody can contribute it. बहुत ही दिग्गज लोग आ रहा है वहाँ तो like I can say you some amazing folks have already come out from here. Like, just go out and just grab all these things out there. So you can get the numpy.zeros, numpy.zeros. It's just you just saying that, I've imported numpy package as np. Just get me all the zeros of this dimension. 5 is just going to give you one single rows. 3 cross 4, 3 rows and 4 columns is what is there. So 3 columns and 4 rows. Sorry for that. So let me just do my zoom it, and so that you guys can go ahead and check out all the things that I'll be writing. So if I just go and do zoom it, no, it doesn't support, and this should be the one. So if I just go and do this, so this represents the number of row columns. So COLOUM columns, and this represents the number of rows. At the end of the day, when you think of all these kind of computation, why they require in a similar fashion, how I showed an image, right? It's just the same old box which is just divide. We just can hold it. We just can do an division. So it just looks the same way, right? You just go out, just get the computations ready. So this is how your images also will be in the real world. So in a real world example, if I just share you how is this insights all about in terms of it, you just can analyze it, right? This is how the images in your entire LED array of your display also looks like, right? This is how you get it. This is how you start getting all the things out there. So anytime any amount of number of pixels that you want to just really get in. So it's still the same old thing. So it's the number of columns just like this, number of rows just like this, and everything will be appearing here. So in a similar fashion, the other ones are np.zeros. Np.zeros is there here, and all the n number of dimensions are already run up here. Oh, sorry for that. I think. All right, this is done. So numpy.array array has already been arranged. And if you think of what is this np.zeros 3.3 comma 4 is all about, it's n dimensions array, which is in a numpy format. So numpy is actually one of the containerized applications that you can think in a Python language. So it's not just Docker, which just had the concept of containers. Unix concept of containers were already there back in like 1970s or 80s, something like that. So 1970s really, this concept really rocked the market. So you can think about that. That's how industry was also. That's how evolving your industry is today. So we all have that, and number of things that you can just really go out and just do is and plethora of operations on it. So you can say that np.full fill up that entire space of values with only one kind of an element. So this is what is being talked here, right? Pi is something that I wanted to add in, and it just needs to get filled up here. So I'm just saying it, just fill all the pi values here. So this is what that function is all about. np.full is just you just saying that, what, there's going to be an np.pi value which is already being optimized, which is already being taken care. All the rounding off and all these elements have already been taken care here. So you need not have to do much of a work here. You just need to just go out and throw that value in that space. And that's it. Everything was already sorted for you. And now, if you want to do something as an empty, very simple. You can just go numpy.empty and you can just look at it. Like it's an uninitialized amount of arrays that you can keep doing. So at the end of the day, when you think of something like convolution operations or anything, it's still going to be the same old thing, right? np.empty is just going to be that kind of a function that you will be looking back at. And I'll be closing my camera because it's taking a lot of bandwidth. So np.array 1 comma 2 comma 3 comma 4 and comma is just going to say that, what, just add it to the next element out there. So within an array, if you just go out and just do that, it's just going to be next to it. But like within those two arrays, if I had added one more here, and it would have been one more metric at the end of the day, but I didn't want to do that. I just wanted to be adding it in one different dimensions. So it just became, so it's 4 cross 2 cross 4, 2 in the rows and 4 number of elements which are there. But now if you just think of it, it's just going to be that one single element right now. So if I just do a is equal to something, and if I just go and do a here, and if I do size of a or something, no, np dot size is just being said that, what, there are 8 elements which are there. So 4 cross 2 or something, which is now 2 cross 4, and this is how it is. So right now, when you think of all these kind of applications which are just getting built, it's a crazy amount of work that is just going behind. Like all of it is being optimized, all of it is already being taken care. So np.arrange is already there. So np.arrange one. is you just saying that start from the 1th element, just end till 4, but the ending element will not be added. So that this is what is being said here. So this thing will always be neglected. So if you think of 1, start from 1 to 5, then it will obviously do that. If you just go till 0 to 5, it's still the same old thing. So one variable is going to be neglected, but there is going to be 5 different elements that are going to be added. So it's just going to be that 5 different intervals that are being considered and now being put in. So let's say here I've written 1, next to it is 2, 3, 4, and 5, right? But now everything here is one interval. So everything is getting considered out there, and it's now being taken care. So the phi is getting neglected right now, and that is how it is all about. So it also works with floats. Floats also is working the same old way. So if you think of 1.0 to 5.0, but now let me just say your type conversion out there. So 1 to 5.0, it still does the same thing. If I just do 1.0 and if I just do 5 or something, see the magic of it. The type conversion is also just going to be taken care. So you know that float value is going to be 62 bits or 32 bits, similar to an int value 16 bit, 32 bits, 64 bits. So all dimensions are always there here. So yes, so right now you're just going to consider it. So now with all these things, so you are going to put that step parameter that's going to be an every element. So repeat it for 5 intervals. That's what you're saying here. So the number of iterations is what you are talking here. So iterations is what you're talking here, and this is going to be the step size of it. And now everything is being taken care. And if you think of something new, this will be the start of it. Everything is getting started. The iterations are already being taken care of here, and also the number of steps are also being defined here. So until 5, the amount of iterations need to happen. So let's just count here. So 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. But until 5 is now being neglected, but 4.5 was being considered. So if you think of 1 to 5, probably there is around 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and that amount of element is already here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 number of elements were already considered here. But if you had started from 0, probably 0, there would have been 9 amount of elements. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, that's pretty amazing. I just did a false math, but 0 is also considered, right? So it can be considering from 0 as well. So it just put in. So perfect. So now everything was being considered, everything was being taken care here. I think we are here right now. So out there. So that's perfect. So you can just do a line space. So you can just do a line space here and you can just get all the things activated here. So it's just going to be a recorded session. So if you have any queries about all these kind of functionalities, just reach out to me personally. It's just going to be good. So linear spacing. So this is what is happening between 0 to 5 by 3. Just get me all different elements out there. And if you just go here and just do 5 by 3, it's just going to be here. And if you just go to do floor division, it's going to be a good amount of integers which are going to be coming in. So everything till 6 was already considered. So linear spacing was already there, and everything between them was also considered. So whatever you did in all these different applications are still going to be done the same way here, but a different function name. It has its own computational complexity being solved and things like that. Computation out there. So all these kind of random integers, random variables which are already being considered here. So you guys can check that out, and also different amount of elements were also being taken care. So now it's just random inputs. So now just go out and check out the random inputs and all these kind of distributions. It's already done for you, and random things have already been taken care. And np.random.randn is going to be random integer values, but number of elements can also be considered. So random distributions really work the same. So n number of integers. So it can be negative, positive, anything was already considered here. So this was done, and everything was sorted. And now the spacing just came out right here. So you can see that the amount of polygon and everything just being distributed and everything is being considered here. So think about this, this is how the functions are. So from functions are also there. So you can think of different functions defined, and you can really give out the number of variables that you want to jot out. And this is how they are, right? Where is going to be my function and the variables which you're supposed to. And now here for you folks, you can get any amount of work done with this. So you can add any amount of digits between 3 to 2, 3 cross 2 elements, and 10 is the range of it, 10 is the step size of it. So you can just move on and on and on and on. So how much ever you want, you just can just keep going ahead. So let's just do a is equals to an a, and let's just do and p dot size of a here. So 60 amount of elements has been added. So 3 cross 2 is 6, and every step has been increased by. Yes, it's now being taken. So about that. So then you can do the company, and also there are a lot of digits that you can consider out there. So array data can be processed, any type of data can be taken care of. So it's all that. So keep that in mind. So of course there were some exceptions which were came perfect. We can just go ahead. We can just start. So D type of it. So I just wanted to arrange it in a form of complex numbers. So complex numbers were also taken care of here. So right, you have people coming way more of contributions happening every single difference kind of functionality. And taking complex variables. Keep in your mind all your computation that you are just doing right now, it's still going to be complex numbers at the end of the day. And all these complex numbers are now just going to be defining your entire fate of that neural network architecture that you're just going to build. So if we just go and itemize the things, itemization is going to work the similar way. So itemization of the things are just some functions which are really required in order to appreciate some sort of an techniques, right? So let's say 1 comma 5, I just wanted to just itemize all those elements between in terms of a complex number. And I just did all that, and let's see the magic of it. See, the magic of it is it's going to be complex numbers with 64-bit of complexity being added to it. So it's a size of 64-bit. At the end of the day, it's just the best part of it. Like all the type conversions, all these kind of operations is just taken care of here. So data buffers are here. So data buffers are always being taken care of here. So np.array 1 comma 2 1000 comma 2000. You can just go out and just do whatever it is. And this is a kind of a bug, if you can say. This is a kind of a bug. So people confuse it with, oh, there's a function value coming up and things like that. But this is a bug. A big bug at the end of the day. If you get a function value, guess what? You're now seeing now being getting ready for an RAM build attack. Anything can go wrong here. So keep this in mind. It's just going to be horrible once you don't define the functionalities here. So keep all these things in mind. It's just going to be that simple move that you just need to do when you're in industry. So 2 bytes reshaping. Yes, you can reshape any amount of elements. So 2 bytes, I don't think so. You just can just go to the documentation of it. It's just going to be there. if the data is a buffer, it's a memory view. Yes, of course, this is what you're talking about, right? So it's a kind of a bug that you can say that it's a memory view that you're getting, but it's kind of a bug even today. Memory views, I can show you that. Memory view in Python. Memory view object allows Python to code access the internal data and objects that support the buffer protocols without copying. But yes, it's still a bug at the end of the day. So keep this in mind. What has to be a buffer has to stay a buffer. If it becomes a memory element, it's just good as being dead. Somebody, let's say, if this kind of an environment is just there in a production environment, and somebody knows, okay, this is the memory view that I'm getting right now, and I'm just ready to do a ramp lead attack on you. So that's it. So keep all these things in mind. Everything is just cost. At the end of the day, it's just going to be money, money, money. So yeah, we just started arranging it. We just got to know n dimensions of it, but the number of dimensions are just going to be one. So at the end of the day, it's just going to be one complete that is just going to be taken care. So one row, an entire plethora of numbers just being added there. It's just the dimension that is being thrown here. So if you can add 6 comma 4, it's just going to be two different dimensions that have already been added. So if you just add 2 comma 6 comma 3 or something, it's just going to give you an error because it's not going to be there completely just for you, right? So let's just say 24 comma 34 comma 45 or something. So the rank is still going to be 1. So t dot shape, it's not going to take place because you are not defining it. So let's say 6 comma 4, right? So let's just do this. All right, so 24 amount of elements added. So 6 comma 4, it's just going to be that value error. But let's say 6 comma 1 comma 3, it's still going to be a value error. But let's see this way. All right, so 6 comma 4, 24, all the 23 elements added, and the rank of that matrix came out to be n number of dimensions. And you can still do that with a lot of things. So the rank is going to be 3. That is going to be the number of dimensions that have been added and things like that. So yeah, that's how it is. So reshaping amount of revel is another function. So if you want to just go out and do all these things, it's just reveal. But I don't know why revel is already there. It's just reveal at the end of the day. So arithmetic operations are here. So you can do floor division, multiplication, pars. So this is par. At the end of the day, if this comes in 2 asterisks, it's number of power of. That is what you are just saying. Not OFF, par of. This is what we have in terms of dimensions. And now we got everything. So broadcasting vectorization is another concept, but okay, let me just show you one thing. So vectorization in NumPy. Vectorization in NumPy is an Python function that returns vectorized versions of it. So all these kinds of operations come handy when we have something called as convolution or multiplication. Multiplication of matrix is a complex task, order n, and we want to just not just go to exponents of the power. We want to go to the logs of the power in order of computation. So this is where all these kind of things come up into the picture. So you can do n number of execution, n number of things out there. And also, there are some function called as upcasting, downcasting. Like it's basically you are just now casting your function into a different dimension. So let's say 8 bits is what you want to code it to. But 8 bits come out with something called as noises as well. So you're now also playing with a trade-off. Keep that in mind because a lot of things are just going to change over a course of time. So all these things have their own approaches and keep that in mind because all these at the end of the day is what you're doing as a computation. So m less than 3, of course the dimensions are now just being considered. So if it's greater than 3, less than 3, everything. So conditional operations can also be done properly. So there are different mathematical applications. There are different mathematical formulas that are also considered here. You guys can do that. There are different dimensions that you can consider here, as well as binary functions that you can so choose. That is what it's all about. And indexing is one of the main concepts here, because I don't want you guys to be so bored that you don't execute all these things. I just want you guys to go out and just get all these kind of functionalities out there. So how are these indexing coming into the picture? Let's say there is an operation that has been done by nth number of pixel by a convolution filter, and that convolution filter really didn't give a satisfactory output. So now you index that metric value, and you now get that metric value out. So things can get a little tougher when you are just getting started, but make sure that you are just getting your other things sorted. Like let me just say you one thing. So you have hundreds of dimensions of code that has already been written here, but like what do you want to do next is a toughest challenge, right? So keep all these things in mind when you just go out and just get all the things sorted. Maybe sometimes you need to just modify some things. So all these things are literally available in the documentation. It's just a cut copy paste that I did from there. I just went on and just get all these elements out there. So keep that in mind. When you just get the things out there, it's just that learning that you just want right now. So I just organized it in a very good looking fashion. That's it. So ellipses are another key term. You can just get amount of element that you just want out there. So it's just two matrices that are being considered, and now one row has been added. So what's the next move that you want to do? So this can be equivalent to this as well, but ellipses also just did the same old thing. So keep in your mind all different things can be done. So of course I can see you something called as Walrus operator. So if you see Walrus operator, it's just in Python. Sorry for that. No, it's an equivalent that you just want to find, and without Walrus, with Walrus, and all these things, it's just going to be still the equivalent of equal to, but way more additional amount of work has to be done. So it's simple amount of work. If you want to know how it looks like, it's just a colon and an equal to, and that's how it looks like. This is how you just even code as well. So let me just go to my Zoom it, and I want to open that application, and I want to do it 4x, and I'll just show you that. So this is how the entire application stack looks like in a Walrus operator. This is how a Walrus operator looks like. So you guys got an idea about it. So let me just go back to my Zoom it for exe. Just do 2x and 3x, because that's what I require. And all these different dimensions are already being taken care. So all the things, when I just think about the computational operations and things like that, this is an entirely not an NumPy cheat sheet wala course, but if you really want to know what are the next dimensions that you need to be working on, I think this is the one that you need to start working towards. And yeah, all these different applications are here, so you can start working on it. And yeah, this is what the dimensionality of all these things looks like. You can use a for operation and just get all the things sorted here. And I think this will be there on my YouTube as well, so just do and check it out. So head stack is here, concatenate is here. So of course you guys know how to concatenate two things, right? How do you join two different matrices? And you know that there are different matrices that I just generated right now, and let me just concatenate it. So comma 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 with an tuple is just going to give you that, and the axis is going to be 0, which is just going to be like you just arrange basically in the dimensions of it. So if it's available, just make sure that the number of rows or the number of columns get their axes done. So you can do 1, 2, 3 and just experiment with it, but axis is always kept 0 initially when you're learning. But if you're doing some complex operations, just go ahead and create your own axes and just start working towards it. And also do check out all the different operations which are already there in NumPy, because there are scientists who have already written neural networks based on the NumPy as well. So they have written amazing set of code. There is some amazing set of values which have already been added. So you guys can start learning how much ever you want. And also keep in mind that stacking of different kinds of matrices really takes in a good amount of stress on a CPU. So if you want to really do all these operations, there is something called a CUDNN, CUDA and CUDNN compatibility. So you guys can go out to these kind of packages and these kind of matrices which are already there being optimized from all these elements. So you guys can check out all these, and now you can come back. And Wolfman language, MXNet, Paddle, you guys can go out and check out any of these frameworks. These are supported for machine learning operations itself. So if you think of what is all these different pixels that are coming right now, it's still going to be matrices at the end of the day. So keep that in mind. So yes, now we have transposing an array. I didn't go deep in all these above functions because it's too much theory if I just go in, but I'll just go after this stacking, splitting of the arrays are done. It's the same old thing, but transposing is something you can do. So let me just say I'm just taking out an array and I just want to put it in different dimension. 6 2s are 12, 6 3s are 18, 8 2s are 16, 8 3s are 24. So the amount of elements that are 24 that are arranged in different ways are now being arranged in 4 cross 2 cross 3. And now if I do type of p np dot size of p, you can see that there are different matrices that are already being taken care. So I can comment this out and I can write what is the t value. The type of p is NDRA. And if, let me just show you one more thing. I did that, but even if I uncomment this, that thing will not be appearing, but this thing will be appearing. So this is how it is also, in your computation, because Python is an interpreter, there are different ways in which it can start interpreting. Since now I'm writing something on an what do you call a Jupyter notebook environment, the last execution is now just going to take a different way of execution, right? So keep that in mind when you think of all these kind of executions that are going to happen. There are different ways that you can go and get the things up here. So if you just do this the last execution, that value will come in. If you just do this the last execution, that value will be appearing here. All right. So now I just transposed it. So you can do the same way. You can just change that matrices into different format and you can still do the same thing. So I am saying 0 dimension. Even if I just remove that, it's just going to be the same old thing. All right. Do this. All right. I just need to put in that 0 matrices because I can do one. No. Oh, 0, 0. Got it, got it, got it. So width to height and height to width, it's now just taking that element here. So see the magic of it. So amazing amount of work, man. Amazing amount of work. And I think this is autofill here, so don't worry about that. So if I do the t dot shape, it's just going to be 2 cross 3 cross 4. Whatever I just gave here, it just got transposed at the end of it. So transpose of a matrix is something like shifting the row to the column to the row. That also takes time and it's being optimized by NumPy here. So everything is considered. So matrix transpose is already being considered. Dot products. Of course, yes, you can do that as well, but keep it in mind, everything is getting too complex as soon as we move down and down and down. But you can do zipped amount of elements here. So zipping of elements also can be considered here. and way more amount of limits can be added in, and you can really define whatever it is. So you consider n number of elements that are supposed to be added in your entire digits or elements, you can add it here. So keep it in mind. So that is how the end of it. So you can go for the second one. NumPy for all. NumPy cheat sheets can be also taken care of from here. So you guys, I'll share you the link here. But yeah, like let's just start with it. Whatever we just saw in the matrices as being operated by your same old NumPy operations can also be done here. So right now you just found out that way amount of elements can be added in, way more amount of uh, people can contribute to NumPy in different functionalities that are required from their industry as well, right? So every industry has a different purpose. So if you think of image processing requires a lot of all these operations which are supposed to be optimized. If you think of something as good as your medical image processing, they require ultra precision with a lot of optimization here. So these people can come and do all different sort of things. So that's what I'm saying, right? And all these things, let me say even one thing, like even arranging a GitHub repo or something requires a metric mentality. So metric mentality is just going to be there in your blood if you're an engineer. So all these things are now being optimized with an advanced version of the NumPy that we are just taking care, and all these things are now being operated right now. So tf.zeros are now considered, tf.random.normal has been added, and all these things are already available in TensorFlow documentation. You guys can go check that out. So let me just explain one by one. So tf.shape of ones. So instead of having np here, I've just added tf here. So it's now coming in. So if I just add 2 cross 1, so 2 number of rows, 1 amount of columns, and all ones are being given out here. So default it will be float 32. That is a precision value that you can do, but you can do type conversion here as well. So I don't think so you do need to do type conversion because it adds a lot of noise into your entire application. So keep that in mind so we can start working towards it. So random tensors can be added. So np.random or something used to be the syntax here, but tf.random.normal syntax is already being added. So now we are defining a shape and the size of it. So if you think of all these different things that are already there here, that's okay. So let me just show you one more trick here. So let me just do this. First execution done, and this. All right. Where is that? All right, it's here. So if I just go out and check out all these different applications that I can start working towards, just see the magic of it, man. I just did an question mark here. This really was that magic here. I just did that and I had everything here. So I need not have to by heart anything. So if I just know the logic, if I just am able to see the documentation properly, and you're just sorted. That's how it is. So in a similar way, there are different NumPy cheat sheets that are assignable to different elements that are already being taken care of here. So import NumPy as NP is already being taken here. And creating a TensorFlow variable is also very easy. So you can create it as a variable, and this is the syntax for it. This is how the syntax looks like. This you can start adding in, and it will start working like a magic at the end of the day. And all these things were being assigned, and all the assignments are now being taken care right now here. So we add in different value as a variable right now, and now the assignment is now just taking care as a different ones. So where does this kind of an application come handy? When you are thinking of, okay, now let's do a mathematical operation on one of the matrices, and now let's just go and get that value there. And this is where every different matrices comes into the picture, and they'll start flowing inside your entire infrastructure. Like, what dozens of images come in every second. And how can we just do the capacity planning, right? Let's say for 5 years you want to do that entire stack. Every time that you just are expecting 5 images, now we are just going to have petabytes of data per 5 years. So processing that, just taking out different things. So probably something like you want to normalize everything to black and white images. So you will still have the same old image, but another replica of the black and white and a lean image will be created, and that's how it is. So all these kind of assignments, operations, and whatever I'm saying right now, in the production environment, when you think of amount of data that ingress and egress happens inside your entire infrastructure, is just going to be that massive mode that is required. And to be very frank, probably ingress and egress is very, very new for you people. That's a pretty big challenge that you need to just go through, because you need to understand industry is complex at the end of the day, and it's complex means it's going to give you a lot of challenges. So just go out and just explore those challenges. You're sorted. So of course there are different assignments that are being taken care. So assignments done. So assignments added, and all different things were considered here. So different ways that you can start adding it. So you can square the a and start putting it here. So let me just go and just type in, okay, so let me just go and do this. F.1 sir here, b, see the magic of it. So squared matrices is all about that matrices coming into picture and you're just squaring it out. So it's just 1 and 1, 1 and 1 only. It's still going to be the float 22, and all these things have been taken care. So if you just think, what is this all about? And if I just do this, there is going to be a metric that is going to say, you know what, this is how I am going to square it. If let's say I say once and everything, it's just going to be the same thing, right? So that operation is already been taken care, but square root of c. C is already being assigned because I had already ran it. So if I just do A, B, C, all right. So square root of A is going to be once. Square root of B is going to be 2. So let's just do C only. Square root of C, and let's see what's the value of C here. C is going to be some float value to some extent. Square root of C is going to be this. Let's see the magic of it. All right. Square root of C is also okay. One square root, what can you do? So let's do one thing. V. Let's do V. Because V was already considered. I think V is supposed to be assigned. Tf dot variables. And V is now going to be assigned. Let's do V. Oh, invalid arguments. Where is this? All right. So let's just comment it out. All right. Don't worry about that. So C is going to be some value. Is going to be some value here. So just see the magic of it. So C was already some value which was already given. So let's just do B or A something. Let's just uncomment all these things. All right, bro. This is going to be a tough challenge. All right, let's do C. Yeah, I think C worked. C is now back to 1. There's nothing to be added. All right, so this is how it is. So all the tensor operations that you're now thinking about, and all these tensor operations just took place in front of you seamlessly. So if you write it in Keras, Keras is going to be much more easier because TensorFlow will be the backend of it, but the abstractions are going to be similar. So let's say tomorrow you just want to move to Theanos, Kefi, or anything, it's going to change. So keep that in mind. It's going to change. It's going to be fantastic. So input.variable.gradient. So you can use gradient types and you can start listing out the results. And let's say I want to print out gradient. Oh, sorry. space and the control, if you just hold it twice, hold it and just do it, it's just going to be there. So gradient types are already being taken care. So the shape of it is unknown, the shape of it doesn't exist, type of it is float, numpy 6.0 version, that's cool. So numpy type is 6.0, and you can still do the same on gradient here. So if I just hold control and space, it just comes out here. Just like that. Simple as that. Just keep all these things in mind. It's just going to be amazing. So all these things can be taken care. And if you can go for the next example here, I'll just show you how this is. All right, I think I've forgotten to run some demos. Oh, right, it's here. So it was a metric and it just got computed, but this was an error. So now it should be running. That's perfect. So let's do one thing. Let's just run all these things still there so that we don't have any hiccups in our execution. Mathematical multiplication just took place. That's all right. And now it's just being taken care here. So using the gradients have already been taken. The gradient functions are also being taken. So let's do an accelerate one for a while. Acceleration, it's also going to give you a numpy of 9.8. Shape is going to be undefined. Float 32 variable is going to be here. So perfect. So if you are going to now just think about what is going to be the input, and the inputs are going to be here. So all these different inputs are going to be here, and np dot size of, oh sorry for that, the function, so it's not giving out any memory variables. That's the best part about it. Inputs are here. Sorry. Inputs are 4,000 amount of elements. So everything with respect to positive and a negative complexities that was being added was now considered. And now if you just go out and just do the target of it, so the V stack is just going to be the same thing, right? Back then, what I showed you, the V stack and all these stacking operations are now being taken care here as well. So yes, so the plotting functions, it just categorize some variables here and there. So input dimensions are 2, output dimensions are 1 or 0. So yeah, that's what it is. So model matmal y is equal to mx plus c. Yes, this is what I did. So this is what I'm putting as a linear equation. So it's a simple thing. It's still going to be y is equals to mx plus c. It's going to be c constant. B is going to be the bias that you're going to add here. So that's going to be the constant here. So input is going to be the x, and weights are going to be that w that you're going to add here. So keep that in mind. All these things are just being sorted for you, and it's just there for you right now. So all these kind of losses, everything got defined. So what next? So you need to define a loss so that all these variables can go out and just do all their learning and all the things. So now you can see that there is a line which has been defined that, this is going to separate all the different variables that are going to be there. Change the different dimensions here. Changes are going to be learned, and this is how it is. So you can still go out and plot out different matrices. And if you just do that history, it's now going to say that, binary accuracy was 0.245%, and all different matrices were already considered here, and the learning happened. So this is how it is. So right now, just go ahead, start learning about all these different applications. So you will go out and just get all the things sorted. And even then, back when I was doing some sort of an application building, I think this is the notebook that I really wanted to show you guys, because this is a GIF generator, because the entire thing that I was always supposed to talk was also a GIF generator. But I will talk about this notebook as well as this notebook here. I think this is Onyx conversion. Yeah, this is the Onyx conversion and everything. So this is the deployment. This is going to be the NumPy for all kinds of data. Okay, I can show you one production. You can just learn about the other ones. TensorFlow, data set and data gen. Of course, you can see that how I did the data gen part here and there. It's going to be challenging if you just going to just do it without a TensorFlow function. This is how the line looks like in a real world production problem statement. And also you can look at the different approaches that I just took here, and all applications are now being done. So now I'm just doing a little bit of placeholders for different data sets. I'm now doing all these different things, and now it's just going to be the same old thing. Earlier we used to do sessions, but now we don't do sessions. It's all global functions that we just type in right now. And now we had the best part about it, so we all just keep doing it. The matrices keep on growing, and this is the accuracies that we are now being able to learn at every epoch. Epoch is nothing but the iteration that is just going to be there at every given point of time. So RNNs were not able to be done by my side because I got a lot of value errors here, but I can start working on them once I just get the chance. So you can see this notebook. It's written in 2.7.0, very recent one. I'm just using the MNIST dataset to train the images. So just look at that. All these different matrices are now being considered right now in here in order to give you that understanding of what this is how computer sees your image back when you're just convolving, just doing all these operations. And all these applications that I just did, instead of session, I'm using TF function, and see the magic of it. It's already been there here for you. And you can see how every iteration is going through some sort of an learning. And after every learning, there is going to be some sort of an MNS data set that is going to be generated. So it's just the same old way of generating the data set, but in a different format. So what you're seeing right now is just one bits of it, but it's going to be plethora of bits of it that is being generated here. So just go through this notebook. If you have any doubts, just reach back to me so we can just go out and just start learning. And now it's basically about the deploying of the models. I love deployments because that's the challenge, because every model on deployment starts behaving differently. You train the model on the same old computation formats and things like that. But now, when you're just going and deploying the models in a production environment, that production environment is just going to have a huge amount of change, right? This is where the definition comes into the picture. All the different things are now being taken care of. All the different things are now being sorted in the production environment. And you know what? I just wrote this set of a code, actually copied it from the documentation, and guess what? This was the only set of the code that I wrote there. Everything as a deployment came out easily for me. And I didn't do much of a work. It's just class 9. It's just saying that this is a shoe, this is a t-shirt, this is a trouser, and a pullover and a trouser, and everything was taken care here. So this is how it is. So whatever I taught you in that kind of an separated out TensorFlow code is now being taught here. That's it. Simple as that. So instead of doing tf.sessions, we are just doing tf.functions here, and everything is being taken care. But now I want to evangelize this because a lot of times, production doesn't work the same way. All of them have their own language to code. All of them have a problem statement to solve. Some people are easy in ML.NET. Some people are easy when doing Python. Some people are very well versed in TensorFlow and things like that. But what happens at the end of the day is that you just want to get out all the models in one format and start working on it. This is where Onyx runtime comes into the picture. Onyx runtime has a huge demand in the market because any targets, any deployments, irrespective of the drivers which are there installed on the entire production environment that we are talking right now, when the deployment happens, is now being done seamlessly without any sort of an hiccups in the deployment process. So back then when you're thinking of all these kind of an application that you're just going to write and just going to have in your production environment, this kind of a notebook comes into the picture where you are now automating through some scripts. That's where Onyx comes into the picture. So keep it in mind, you guys can go out and check out any amount of notebooks that you can write, any amount of production issues that you can just go through. Sometimes just convert it to Onyx and you are sorted. And this is how the code looks like. You just go import the Onyx runtime and just start working towards getting that Onyx runtime, right? And testing the asserting all the classes are there. And now when you just pull out that image and you just start working towards it, the deployment comes out to be a very fruitful one. And this is how it is. And if you want to convert a TensorFlow to Onyx, this is how you do it. So you do TensorFlow deployments and things like that. Onyx TF is also here. And what you just do is you just take the inputs and outputs, set it up, and what you do is now just throw it out here. So you can download any amount of elements here, but best way is to convert it for the production environment. So more you try converting format, less of the noise is getting generated for the deployable model, and that's going to be much more easier when you are deploying at scale. Let's say this same old model that I'm having right now has to go and sit in a mobile application, has to go and sit in a TensorFlow JS environment, has to go and sit in an what do you call, an cloud rack or something. So all these Onyx is being optimized to an extent where all the deployments are now being taken care, and if you can see, all the different neural networks are also being considered. So you can see this is an how you describe it, and every epoch there is an accuracy and everything. So at the end of the day, accuracy was 98.93%, and all the resolution of the models were now taken care. And guess what, the deployments happen and different kinds of the things come out, and all these deployments will now go to an efficient net deployments and all these things, and now they will be modeled out. The deployments will also happen seamlessly. This is how it is. So every time when you think of all these kind of deployments that are going in production environment, it's just going to be a little chaotic, but once you start working, it was just going to be easier. So I think that's what I wanted to convey through this session, because a lot of times when we talk about an end-to-end production environment, there is going to be huge amount of demand that is going to be created over a course of time. But now this learning is just good enough. You can just go back, see the notebooks, start learning from it. I'm just going to come out with a lot of Onyx series and things like that. So you guys can go and grab your piece of the code from this docs that I'll be sharing in the description, and everything will be sorted. And any open source contributions on those notebooks are also welcome. So please do hop in. So we'll be getting everything started out there. Fine, guys. So I think Anirudh, it's the end of the thing. And if I can share you the docs, I can share you my LinkedIn as well. So let me just do that. So when you just go follow my LinkedIn, it's going to be much more easier for me as well. So just go through the LinkedIn. So this is my profile. So just go through that. Just follow me here. Just follow me on YouTube. Let me just mute it up. Which was Ryan. Subscribe to my channel. It's going to be good if you just guys can do that, because a lot of shows are coming up, a lot of things. So Dev Station is being started out by me. I'm starting at Dev Station as one of the shows on my YouTube channel. Just go out and do that. And of course, there's DevStar Op show that I'm coming up with every weekend. It's going to be there for you folks. So you guys can see that DevStar Op show. So this is the name of it. So DevStar Ops Show. So do check this out on LinkedIn. So it's a pretty famous one. Of course, many people have already joined in and they've already taken the use of it. So that's it from my side, folks. Any question, any queries, do reach out to me on LinkedIn. Of course, you can reach out to me on Twitter, so you guys can start learning about it. So yeah, anything that you just want to ask me now, you can ask me, and later on we can go out and just work on the different projects that you really want. Of course, there are a different amount of Onyx that we just wanted to do. There's an Onyx runtime. There's a YouTube channel on Onyx. So Onyx runtime is here. So I'll just go ahead, share my screen. Onyx runtime is here. So guys start learning from here. So that's what I would say for you folks. And also, is your developer community is here. So do subscribe to our channel. We have tons and tons of content coming up. So, yep, that's it from my side, folks. Thank you so much. We'll end the show. And this is a recorded session. If you guys have any queries, please do reach out to me on LinkedIn. So this is a recorded one because I was not able to be available for your college. So yes, I think Anirudh needs to be called and so on. And guys, like there is a lot that we can just start working towards. So keep that in mind. You can start working on a lot of things. And also, one more thing, you guys can go and check out my newsletter, and that's it's DevSecOps and nothing else. I think I can show you my articles as well. So do subscribe to my channel. Amazing articles I just write. I just love writing as many articles as I want, and this is the newsletter. So do subscribe here so you can get anything up here. We can start working on it. And that's it from my side, folks. Thank you so much. And the recording will be available there for you folks. So, anything that you just want, just reach back to me, and we can do a lot of sessions like this. We can do a lot of sessions like this. And of course, if you want to just reach back to me, uh, I am ending, but this guy is not here, so that's not a problem. So you can reach out to my features section here, and you can see a good amount of notebooks that I've already written. So n number of notebooks already written. So just go press on it, press on next. You will find n number of notebooks, and that's it, folks. That's it from my side. Thank you so much. I'm leaving the call, and it might have an extension afterwards, but just enjoy the show. That's it. Thank you so much, folks. Bye.